Now you've seen a few spaceships, some of the vehicles we send in the sky. That was a very odd shapes, and the spherical one is a pretty good shape. And our own Earth is a spaceship. It's a spherical spaceship, only 8,000 miles in diameter. We're zooming through space around the sun 60,000 miles an hour. And the galactic system itself moving fantastically from the other nebula. Our total speeds get up into fantastic kinds of hundreds of thousands of miles an hour. I often have people say to me, because I do travel around our little spaceship surface quite a lot, and people say to me, I don't understand how you can stand all that travel. And I say, obviously you don't know what you're doing. And here is our spaceship Earth, and we have life. We've had human beings aboard it for 2 million years without even knowing they're aboard a ship, including yourselves. You're not thinking that way. But if you begin to realize you are on this tiny ship, things are very, very different from the way you thought about them in the Roman Empire. All the periods of history when most of the philosophy has been developed, and all the ways of looking at things that we have in our school books and the universities, comes from eras of man thinking the Earth flat. All the Roman Empire, Genghis Khan, all of them, at that time they thought the Earth did go to infinity. So the empire was simply the known area. And who controlled the known area? And out beyond the known areas of the empire, you came to some very dangerous people, and beyond there you came to dragons, and beyond there you better not go, because it's just getting But if it went, the main thing about all this is that if it went to infinity, which they thought it did, then there were an infinite number of chances that out here there could be something that would take care of our problems. If we just keep exploring a little more daringly, we'll come to the great roast beef mountain.
We have with us today an unusual person, rather a remarkable person. Mr. Fuller is described as an architect. He is that because of his intense concern with living space. But he is something more than an architect, because his obsession is with the architecture of the universe. We all have heard of Mr. Fuller's invention, the geodesic dome. It is now seen all over the world. It is a brilliant use of space and material. Then the world map and other items. But what is far more important, Mr. Fuller has shown how to get the maximum from the minimum material by making the most intelligent use of the resources available on Earth. He has often spoken of how he was born with the handicap of farsightedness. As a child, he could see the far-off things clearly. And as a young man, he lighted upon the idea that if Einstein is more right than Newton, then the mind ought to live in tune with the speed of light.
Synergy means behavior of whole systems unpredicted by the behavior of their parts. The most extraordinary example of it is what we call mass attraction. One great massive sphere and another massive sphere hung by tension members are attracted to one another. We find then there's nothing in one sphere in its own right that predicts it's going to be attractive to another. You have to have the two. It is then the synergy which holds our Earth together with the moon, and it is our synergy which holds our whole universe together. Synergy is a companion word to the word energy. Synergy means behavior of whole systems unpredicted by behavior of any of the parts. It's the only word that means it. The fact that humanity is unfamiliar with the word means that humanity does not think there are behaviors of wholes unpredicted by parts. The very essence of our solar system or whole scheme of our universe is held together by these synergetic behaviors.
I became interested in what myself, as a very average, really low average man, might really have that could be turned to advantage of others. And if I could make such discoveries, and they would be really experimental, they might this might open up other people making such discoveries, because what I was hoped to look for was not recognized in any school or any of the conventional ways of treating with young people. And I saw young people really discouraged on a beautiful spontaneity in the child that was continually frustrated in one way or another. So I said, as much as the parents are part of the environment of the child, I've got to do something about those parents. For instance, a mother is very tired, and she's also worried how they're going to pay the rent. and the child does something, and she doesn't understand, and she just reflects it by taking it out on the child. Happens many, many times. So I said, I must do everything I can to have an environment where that mother doesn't have anything to worry about the rent, and she doesn't is not tending to get tired, by which she will, her real spontaneity would be to be very attentive and thoughtful towards the child. In 1927, I was completely inspired by the birth of a new child, our first child having died 5 years earlier. And I had good cause with our first child to feel that children are endowed with a great deal more than any of us know, that every child may be born a great genius, that they simply lose these faculties of genius at an early age due to the non-realization of their presence by the parents and to environment. I said, I'm really going to give the rest of my life to the new young life. I pledged both to my daughter who died and the daughter who's now born. I was committing myself to humanity. Money, I think, is absolutely irrelevant. I see it's really man and his environment and his time, and you can get the environment to begin to do work with you. I had to expand what I'd already learned by a great deal. I had to unlearn a great deal that I had already been taught. I'm aiming at the kid to give it that maximum chance, so it won't be misinformed and can get all the information it does want and does need in order to be able to understand this universe and operate its spaceship properly within that universe. How do we, within that big context, find out how we use our mind, our experience, then to its highest advantage for the others in the shortest possible time? That was a challenge. Out of this, then, in due course, came a great many designs, because I said, I'm committed myself to reforming the environment, not reforming the man. Absolutely confident if you give him the right environment, he will behave favorably. And I know that I could, by employing the kind of capabilities I've learned, that are employed in building a battleship, how you do more with less. I'm so convinced that the more with lessing could make it possible for us to do so much with so little that we could take care of everybody, and there need not be any of the suffering that is around the world. In 1927, I decided man was operating on the most fundamental fallacy. He was operating on the basis that man was supposed to be a failure, and therefore he had to prove his right to live, and each man then thought he had to say, I can show how I can earn my living. The other people are supposed to die. I decided that the fallacy was that man, as designed, was designed to be an extraordinary success. His characteristics were just magnificent. And what would be necessary would really be to find out what were the great comprehensive patterns operating in the universe, how then the metaphysical man as mind could become the master of the physical. So I then said, I think my first grand strategy of finding out how to use the world's resources so they will take care of everybody would come back then to how to take care of his living equipment. This brought me then to what I call the dymaxion tower house, a 4D tower house. And it was a 10-deck building which was so light and so strong, as finally engineered, that it could be carried by the Graf Zeppelin, which was about to be built at that time, and was perfectly flyable economically to the North Pole, where it could be anchored. I gave myself then the task of designing a building which would house an airplane maintenance crew, which we'd be able to install in remote places in the Arctic, so that we'd have stepping stone flights to Europe. Once I'd proven this feasibility of flying a whole building 10-decker to North Pole, I then turned to the idea of the single family. So I developed what I call the single family dymaxion house. Looks like a house hung in a pole simply because there's a wire wheel construction, has less weight, so I turn the wire wheel over on its side. The hub is now a mast. For a family of 5, had great space in it, good-sized bedrooms, each with a bath, a large living room, utility room, library, sun deck in the top, and hangar and garage down below. The whole thing came out then 3 tons. That is, I found a house equivalent to that kind of facility with all the accessories in it. And the conventional way of building at that time ran over 150 tons, so that this was a very, very small fraction of the total weight. This then brought me to a whole series of additional experiences. Later on, 20 years later, in 1947, I developed in the Beach Aircraft Company in Wichita, Kansas, the first actual dymaxion house. I built then with the aircraft industry extraordinary structural capabilities. Made across all of aircraft aluminum. The mass itself was stainless steel. It consisted of 7 tubes bound together in a hexagonal collection, and each tube weighed only 10 pounds. It was 22 feet high. Top of it, you'll see the great ventilator. It's 18 feet in diameter, and rotated as does a wind tee on an airport. A low pressure area occurred at this point where we then had the ventilator tail open. We pulled the airs of the house through the completely air conditioning. You're going to see the actual dymaxion drilling machine coming out, but as a service industry, handled as the telephone company does, installing what you want where you want it, just where the telephone company installs the telephone booths along the highway, and you'll be able to call up and say, I'd like to have my drilling machine over here and there, and the autonomous equipment will be coming out of the airspace technology, and so I think we're just about to realize it. I'd gone into the building world after I'd been in the world of this very advanced technology and found it crude and the exactly other end of the scale of the competence when the science was putting into the weaponry world. And I was so shocked to find how little man had in the way of science. I found no scientist ever looked at the plumbing. Dymaxion bathroom is a solution of the place where we go in to bathe and wash and to take care of the human processes. I was able to do a whole bathroom, including what we call a manifold of plumbing, all reassembled, everything, and a manifold of wiring, and the manifold of the air conditioning for only 450 pounds. In 1933, I turned the money which I'd been given into cash I had in my pocket, and I arrived in Bridgeport, Connecticut, to produce this new ground taxing quality of the omni medium transport. Because it just wasn't going to go on the ground, I knew people would call it an automobile. It wasn't designed just to be an automobile at all. She was so extraordinarily stable, my center of gravity was very, very low, and for the first vehicle that ever had the center of gravity forward to the midpoint of the wheelbase. It did prove to be a very good vehicle and did have very high efficiency. With 11 passengers, I averaged over 22 miles a gallon. Sometimes I got as much as 30 with 11 passengers. It's very, very high. A front steered car with the kingpins can only steer up 34 degrees angle. My rear rudder post I could turn so I could give it 90 degrees rudder if I wanted. This meant then when I wanted to come into the park, there would be a space just say 6 inches longer than my dymaxion car. I would simply bring my nose into the curb and then throw my rear wheel sideways, and she'd went right and flop like that. Look at all the seals down there on Bear Island Ledge sunning themselves in the... Look like a whole lot of rocks. There's all seals lying up the seaweed there. A lot of cormorants behind them with long necker. In approximately all of the yesterdays of known 2 million years of man on Earth, man has been so very busy satisfying his innate hunger, thirst, reproductive urge, that he's had very little time for questions about why man happens to be in the universe. But today we have so much of our environment under control that our young world has considerable time, and a great deal of the problem of the young world today is trying to think about how they happen to be here, and is it worthwhile now that you do have some time on your hands? What ought you be doing with it? I find that there's never been very much more of opposing of the question than that of Shakespeare when he spoke about man as a theater goer, to be pleased or displeased with his play of life. When I began to try to find important questions that seemed to be fundamental, needing answer before we could get other kind of answers, I felt that the question of whether man had a function in the universe, whether he was necessary to the universe, seemed to be the most important one to be solved. To understand man's function in the universe, you'd have to have immediate reference to the most important scientific findings of our recent decades. Just in the last decade, we've come to the understanding of the astrophysicists. Those are people, the physicists who are dealing with the very largest patterns of all the energies and all the stars, as well as thinking in the terms of the atoms. An astrophysicist, being a physicist, he's concerned with the nucleus, but he's also concerned with the very largest. So he's both macrocosmic and microcosmic. And he has to understand the interrelationships of the very big and the very little. And he's come to the realization that no matter how that we have in the vicinity of our particular planet, the chemical elements of high order number like uranium and the isotopes of uranium, these large number aggregates begin to come apart gradually. They have, after a certain amount of time, they separate into a plurality of other elements of lower order number, so that there is in the vicinity of Earth a continual separating out into lower order number, working towards the hydrogen. But the fact that there are high order number elements in the universe means that there must be some place where they occur. So the astrophysicist, dealing in both the stars and the nucleus, feels that it's very probable that the high order number elements have been the consequence of the very powerful forces operative in the star, where not only do you have the great explosive forces outwardly, but there has to be, every action has a reaction, so the implosive forces, and then within the implosive forces of those stars, we get the higher order elements. And we are finding that our Earth is receiving this kind of energy in the form of stardust, cosmic radiation, continually, so that the higher order elements may probably have been delivered to us from our celestial resources. Now, we also do know that core of Earth, we don't know this, but the working assumption of core of Earth really relatively very few elements, but very large numbers of chemical elements present on our Earth are all near the surface crust. They seem to have come to us from other stars. And so that's a perfectly reasonable part of the scheme. But these physicists then point out that no matter how much things come apart, they finally do not come any further apart than the interrelationship of the proton and the neutron. The proton and the neutron always and only coexist. And the proton and the neutron also have, every action has to have a reaction, has to have also a resultant, which is not the same as a reaction, because there's always a time lag between the reaction and the resultant, because no event is instant, so it always has some duration, and the resultant is different. The speed of light had not been measured till we came into this century. And with the measurement, and nobody even supposed that light had a speed.
Therefore, all of the scientists before our century, looking at the stars, assumed that every star was always right there. We had what we call instant universe, which was a complete misapprehension. If you had instant universe, universe was in a sense a thing, a static. With Einstein's paying great attention to Michelson-Morley's experiment, which demonstrated that light does have speed. It takes 8 minutes for light to get to us from the sun. It takes us light 2.5 years to get to us from the next nearest star. That you're looking at one star out here at night, and it's a live show taking place 30,000 years ago. The light's just getting here this second. Right next to it is a star, a live show 3,000 years ago. Right next to it is a live show 20 years ago. Einstein said quite clearly, our universe is an aggregate of non-simultaneous and only partially overlapping events. Each one of these is transforming. Some of those stars are not even there anymore. We have then, he said, a scenario. Universe is a scenario. As, for instance, we have a man who's born, and then he gets to be a father, and he has his children and grandchildren, and then he dies. They go on. But looking at the sky here, we're still seeing grandfather. So we're getting really the scenario report to us in an odd manner, very disorderly way. But universe is scenario. Now, that is just of this century that we think that way, and society is not yet thinking that way. Also then, in view of the entropy, Einstein said, I see that this child is growing up and getting bigger. Therefore, I don't think, as the scientists had been thinking up to then, that energies were always, the universe is running down. He said, I think when the energy leaves this local system, it is taken on by another system. Scientific review of experiments shows that's exactly what was going on. So only in this century have we come to discover that the energies are not lost, the universe is not running down, and our new norm is Einstein's norm, which is that energy is always transforming, and the very highest velocities at which things can transform or change, the rate at which energy goes right away from itself radiantly, which was at the speed of light. So 186,000 miles a second is normal. Anything we call matter is where the energies trip themselves up like knots and develop local constriction and become something we call matter. But they're going around at the same speed, but very, very locally. Every local system giving off energy then must be affecting other systems. We find this is exactly what goes on. All the living creatures, for instance, are continually affecting the environment. The environment becomes changed, and the changed environment affects the creatures. This is the way in which the universe is evolving. Therefore, change is constant and change is normal. It's only since Einstein that change has become normal. I said we have all the physical, anthropic, and increasingly disorderly, and we have our own little Earth demonstrating it's a place in the universe where energies are collecting and increasingly orderly, and we have man amongst all those mammals, and we begin to try to understand him. And he has a capability that we don't find in any of the other living creatures. That is what we call mind.
Now, we have this whole phenomena of just being able to communicate. And I would come then to something I did this year. I spoke before the American Association of Neurosurgeons. There were 2,000 of them in Chicago in their annual Congress. And I said that, of course, as you know, for the last 2 decades, we had neurologists and physiologists probing the brain with electrodes. These men who've been doing so have discovered a great deal about the process, this information handling and storing that goes on here, and communicating as it does. And it's a very extraordinary kind of telephone system. And they say, however, that regarding this total system, that it's easier to explain all the data they have if they assume 2 prime variables, one which they'll call mind and the other brain. It's easier to explain all the data with 2 than it is they assume only brain. And why? Because they find that there are conversations that go on over the telephone system that are not explicable as feedback of the system itself. I differentiate between mind and brain very clearly. Brain is part of his physical equipment. There's so many cubby holes, every neuron is where he stores, like our film here or tape recording,
he has every experience he has, he puts into his memory bank. The memory bank is the brain. Mind and mind alone reviews the total inventory of experience, and from time to time finds something running through all of them. As for instance, if you had a stack of punch cards, they're all the same perimeter size, say 4 by 5 inches, full of holes. Look very random to you and I. Stack them all up vertically with guides to the edges, and put a light below. Suddenly you see 2 holes through which light comes through. Those 2 holes are constant to every card. This is typical, we call a generalized principle. It holds true in every case. In literature, there's something called generalization, which is trying to cover too much territory too thinly to be persuasive. But in science, we have a generalization. A scientific generalization means discovering a principle which holds true in every case and never fails. We have a man going through the forest, and a lot of trees have fallen. There have been great storms, and he finds he's walking along on top of a tree to try to get from here to there, and the tree begins to sink kind of slowly like this, and he says, "What's going on?" He retreats back here. And then he gets down here again, and goes down slowly. He sees a tree on top of is lying across from another tree, and the other end of the tree he's on is under a great big tree, and he tries to go over and lift it. He said, "I can't lift a tree like that," but every time he comes over here, the big tree is lifting. So he said, "I think I got a magic tree," and he drags it home, and everybody worships it. But pretty soon, his wife says, "I think any tree will do," and that's really a generalization. And this is our principle of leverage. For instance, I'll just take it. Here's a piece of a good stout wood, and we get down here to a stone. I'll try this. Sure enough, I lift a big stone. Whatever the distance from the fulcrum to the load is your basic increment. Come out 1, 2, 3. I'm now able to, my effort will lift 3 times my own weight. It doesn't have to be wood, it could be reinforced concrete. That's the typical generalized principle. Not so many of them, they're all interaccommodative, and they work anywhere in the universe.
Take a piece of rope. And I take this piece of rope and I begin to tense it very, very vigorously. And the more vigorously I tense it, the tauter it becomes. When we say taut, we mean the rope contracts and gets harder and harder, which means that while I'm only purposely and consciously tensing it, it is at 90 degrees to my tensing is getting into compression. So we're discovering I hear many architects talk about just using tension. I find that they can't have the tension all by itself. There's compression occurring at 90 degrees to the tensing. Now I take a number of steel rods, round rods of the same size. Each one is long enough so that if I pushed it like this, it would bend very easy. It's very slender. I take a bunch of them and compact them as tightly as you can, get them into the hexagon, the honeycomb pattern, what's called closest packing. They can't get any closer together. Now I've put some bands around them like this, wrap them together. Now, when I load the whole of them as a group, as a column, from the top here, the rods can't bend towards each other because they've already packed the closest they can go. They can only bend away from each other. There's nothing to stop them opening that way, except there are some bands around it. So as I load this column, like a cigar, its girth tries to keep stretching. It gets a little fatter and fatter. As it gets fatter and fatter, it means the girth goes into tension. So while I'm purposefully loading and compression, it goes into tension at 90 degrees again. So we find tension and compression always and only coexisting.
Another of the generalized principles of the principles of wave behavior. Throw a stone in the water and you got a most beautiful wave. See a circle emanate like that, and then even though there's another big wave coming, it had an integrity all of its own. Let's identify a man to start off with as what I call a pattern integrity, and I'd like to make clear what I mean by pattern integrity. I'm going to take a piece of manila rope, and then I'm going to splice into it a piece of cotton rope. Splice on the other end of the cotton rope a piece of nylon rope. I'm going to make the very simplest knot that I know, which is simply to go around like 360 degrees in this plane, 360 degrees in that plane. I'm not going to pull it tight. There's that knot where the rope has not done this. I have done it to the rope. Then I can slide this knot right along. It's still a loose knot. I haven't pulled it tight. I slide it along on the rope. And now it leaves the manila, and now it's on the cotton. Now I keep sliding it along. Now it's on the nylon, so suddenly it's off the end. We say,
the knot was a pattern integrity. It wasn't manila, it wasn't cotton, it wasn't nylon. Though cotton and nylon and manila, any one of them were good to let us know about its shape, what its pattern was, but it was not that. It had an integrity in its own. We drop a stone in the water, and the most beautiful circular wave emanates. And I then try it in milk, and it works as well. I try in kerosene, so I discover that wave is a pattern integrity. And then the next thing that I try is say, I'd like to know about that wave apparently isn't just water, and it isn't milk, and so then I try sprinkling sawdust all over the water very neatly, make beautiful film of sawdust. Then I drop one piece of red popcorn on it, and I put a transit and a moving picture camera very carefully aimed at that red popcorn. We drop the stone over here in the water, and the yellow sawdust makes a wave, and suddenly the red popcorn goes out from the center of the earth, into the center of the earth, comes right back where it was. They simply went in and out towards the center of the earth to accommodate the wave, to let it go by, just as a piece of rope accommodated the knot sliding along on it. I want you to think about yourself now in the terms of a moving picture scenario. You've all seen moving pictures run backwards where people undive out of the swimming pool back on the board. I'm going to run a moving picture of you in a backwards manner. You've just had breakfast. Now I'm going to run the picture backwards, and all the food comes out of your mouth and on the plate, and then the plates go back up onto the serving, and then they go back in the things on the stove, things go back in the icebox, they go back into cans, come out of the icebox and in the cans, and they go back to the store, and then from the store go back to wholesaling, and then they go back to factories where they're going to put together, and then things go back into trucks and then ships, and then they finally get back to pineapples in Hawaii, and then they go, the pineapples separate out and go back into the air, the raindrops go back into the sky, and so forth. And within a very fast, accelerated reversal of a month, practically everything has come together that you now have on board of you, which is gradually beginning to be your hair and your skin and so forth. Was a couple of months ago, some air coming over the Himalaya mountains and so forth. In other words, you got very completely deployed, and so I want to begin to think about yourself in an interesting way, as each one of these, there were trajectories. If we'd had a tracer, some way of putting tracers on to make photographs, we could see these very remote chemical elements gradually getting closer and closer together, and finally getting into these various vegetable places, and in the roasts, and in the tighter in cans, getting in the store, finally getting into just being me, and then being temporarily my hair, my ear, some part of my skin, and then that breaks up and goes off and gets blowing around as dust. In other words, I'm coming to a concept of each one of us being a very complex set of slip knots sliding along on a very complex pattern integrity which you're born with. I took off 70 pounds recently because I was overweight. I said, who was that? That wasn't me. I've taken on over 1,000 tons of food, air, and water since I was born, and I'm not to any of that poundage at all. When I die, I still would be somewhere around 140 pounds, and you can throw that away because that's just yesterday's cereal. When men die, they've been weighed many times, no weight is lost. Whatever is you and I is this metaphysical. Every wave in the universe has its own integrity. It's perfectly easy to understand in the total great scheme of universe, of energy. There'd be areas of universe where energies are collecting and areas of universe where energies are being distributed. The geophysical year, we received, it was found by the scientists around the world, we were receiving somewhere around 100,000 tons of stardust daily. This is out of that stardust on the surface that we begin to get the chemical combinations that make possible growth, and finally we get these little turf covers, where then finally biology gets going as grasses. We also receive enormous amounts of radiation all the time. We call it cosmic radiation coming from the other stars. The sun, of course, is a star, is the nearest one. So the sun radiation is by far the most prominent of all of our energy receipts. And the energy from the sun is not just reflected from our ball as if it was polished mirror sphere, which would reflect that radiation away, not take any in. Then our Earth is impounding enormous amounts of that sun radiation. First in the atmosphere. How does it happen? The Van Allen belt begins to bend the radiation, and then the atmosphere bends it even more. Our very spectrum colors, the blue is a consequence of it, the blue of our sky, and bends it more and more. And when you find it gets 3/4 of Earth is covered with water, it gets the water and bends even more. And you just put a stick into the water and you see how optically it seems to bend. So the series of these bendings finally gets it moving approximately horizontally going in the circumference of the Earth. So it's enormous amounts impounded as heat in our water and in the atmosphere, and in the water it gets into the Gulf Stream and the Japan current and so forth. Now, we have then clearly our planet Earth is a place where energy is being inhibited, where energy is being concentrated and collected, as in that stardust. On the Earth, then, we have operating in this stardust collection at the surface of it are biologicals. And in the sea, we have the biologicals as algae, and on the dry land here, we have the vegetation. You and I can't take in enough energy through our skin to live on. In order to have something we call life, it must be regenerated. And because every system is entropic, life must take on much more energy than it gives off. So we have to have ways in which you can take the energy in. Now, radium is all invented for us. In fact, it's all invented for us. We didn't have anything to do with our ability to digest food or to have hunger at all, or to be thirsty and take on the right waters, or to breathe in our air, to oxidize. All those things were all invented for us. And the things we need chemically to do it were all there waiting for us. And I find then that man, having to be regenerated and having to take on energy and can't take it in enough through his own skin, and the only place where we can get our energy from is from other parts of the universe, primarily from the sun. It's very interesting then to discover that it's already been designed to have these trees and all this grass is here. I'm looking over 1 million blades of grass right in this tiny little area, all designed to get the most possible surface to impound the most energy. And impounds it by photosynthesis. The photosynthesis is a beautiful chemical process converting that sun energy into beautiful molecular structures. Now, we were looking for a phase of the universe where things are not only contracting and increasingly orderly, nothing could be more orderly than beautiful molecular structures. We find all the vegetation is all anti-entropic. All systems, as viewed from inside, are concave, and as viewed from outside, are convex. Concave and convex are not the same, because concave converges and conserves energy, and convex distributes it. So concave pulls the radiation together, and the other one diffuses it. So they're not the same. They're not the same energy effects, yet they always and only coexist. Then we have the physicists, as said earlier, giving us a proton and a neutron, which always and only coexist. So now I have 3 always and only coexisting phenomena: tension, compression, concave, convex, proton, neutron. Now I've developed something called theory of functions. Theory of functions, where you have x and y as the 2 functions, which vary in respect to one another. And I find then that we can have then x stand for the tension, or for the convex, or for the proton, and y could stand then for the compression, or the concave, or the neutron. Now, and these then to take care of any of these covaryings. So it's called then the theory of functions, and embraces all of them. Now, then go on further and notice that I can take a word like relativity. Now, you can't have relativity without an x and a y covarying. And then you have the word complementarity, as we learned earlier. But you can't have complementarity without a minimum of 2 covariants, something complement one another. So, but I find complementarity and relativity not the same. So I'd like to have something that embraces both of those, and I have the word universe. Now, I'll come back then to start off with, I said I had a piece of rope and I was tensing it, and I didn't have any piece of rope at all. I've tried this with audiences with thousands in the audience. Nobody ever says you don't have a piece of rope. This is what I call a first-degree generalization. Everybody in the audience has had experiences with ropes, many, many pieces of rope. And I just said it was nylon or cotton or what it was. They found, so long as I didn't say something that contradicted the experiences all of them had with any rope, this is what I meant by a generalization. So it's a first-degree generalization to say, I take a piece of rope. It was a second-degree generalization to discover the always and only coexisting tension and compression. I knew something else completely different regarding this thing I'm tensing. Now, it's a third-degree generalization when I took the always known to coexisting tension, compression, concave, convex, proton, neutron, and I put them in the theory of functions. Because here is a generalization which embraces a plurality of generalizations, which are very, very powerful. Then I go further still, and I say relativity, and this embraces the theory of functions, but we had the complementarity. We had one that embraces both those and came to the universe. So we find then that what we call, my taking a piece of rope is called a first-degree generalization. Second degree is concave, convex. Third-degree generalization, theory of functions. Fourth-degree generalization to say relativity or complementarity. Fifth-degree generalization to say universe. Each one of those was a generalization of generalizations. Mind has the ability to deal in the generalized principles, this absolutely abstract, weightless phenomenon. And as far as we can find out, no animals employ those generalized principles. What is really seen to be unique about man is his mind. It's only the mind that looks over all those punch cards and suddenly finds the hole through it.
I remember the first time ever looking back in the wake of my ship and seeing all the whiteness and the foam, and I said, that's white because it all consists of bubbles. And I said, how many bubbles am I looking at? And I find I'm looking at fantastic numbers of bubbles. Here comes in this wave. Look at all this whiteness, all those bubbles. Beautiful, beautiful bubbles, every one of them. I said, now, I've been taught in school, in order to be able to design, because a bubble is a sphere, you have to use pi. And the number pi, 31416, on and on goes the number. We find that it cannot be resolved, called transcendental irrational. So I said, every time nature's making one of those bubbles, how many places she carry out pi before she discovers you can't resolve it? And at what point does nature decide to make a fake bubble? I said, I don't think nature's turning out any fake bubbles. I think that nature's not using pi. So this made me start looking for ways in which nature did contrive all of her menstruation, her spontaneous associations without using such numbers. And I'm quite confident I really have found her coordinate system where she doesn't have any irrationals whatsoever. Because in the chemistry you find her associating H2O, not H pi O. Always whole rational low order numbers, all of associating dissociating.
I'm not trying to imitate nature, I'm trying to find the principles she's using.
Now get that seaweed is kind of most extraordinary structuring. Very, very strong in tension, and we have these beautiful little pneumatic bulbs to make it float just exactly at the right depth in the ocean, and to just exactly the right depth for her to prosper and do whatever it has to do. I get down to the details of this, looking at it like our friend's plastic and all those little mass attraction, the curls that go on there. Nature's formulations are just, to me, absolutely unbelievably magnificent.
And I asked if any of them in the audience, as scientists, would any of them say they did not see the sun going down? and no hands were raised. They'd had 500 years to organize themselves in relation to their fundamental information and had done nothing about it. Having taught our children about arithmetic and having given them a chance to draw pictures, we then say we will show you how you can coordinate that picture with the arithmetic and to be able to make some calculations, something we call then geometry. Geometry, the word measuring our earth, it means. And we start our children off by saying, we're going to give you a plane. We start off immediately then with that planar concept of universe going laterally to infinity. We say to the child, here is a line, and the line goes to infinity, and the plane goes to infinity. This is very perplexing to a child, because the child has the same attitude as any scientist who likes to deal in experimental information. He finds, in talking about infinity, as the teacher seems to, they're talking about something that's not as yet been experienced. I'm really convinced that our troubles spring from our continually feeling so sort of comfortable. That's the way I learned it. That was good enough for me, and we did get along, and we did have a lot of fun, and so forth. So let's let it go that way. It's too much trouble to rewrite the books. We bought all those libraries. We taught all our teachers to teach it that way. So you just keep on teaching error. And the plane geometrical figure is described, for instance, as a triangle. A triangle is an area bound by a closed line of 3 edges and 3 angles. A circle is an area bound by a closed line of equal radius from a point. A square is an area bound by 4 equal length sides and 4 equal angles. All of the geometrical figures are areas bound by closed line, which is then teaching our children that which is reliable and computable is always on one side of the line only. On the other side of the line, we don't have any definition. Why? Because it goes to infinity, therefore it cannot be defined. Because of our starting with plane geometry and the nonsense of the infinity, we have given then a basic bias. We start our children off then, only our family is safe. We're on the understandable side of the line. Our town, our country is always that way, this bias. Now, when we do deal in what we call systems, and systems are conceptual and they subdivide total universe into without an outsideness and an insidedness and a little bit of the universe which is the system itself. And systems return upon themselves in a plurality of directions, whether they're spheres or cubes or crocodiles. And it is a quality then of systems that they have unit surface. Now, when we draw a closed line on a closed surface, as for instance the Earth, we automatically divide the total surface into 2 areas. As for instance, if we draw a circle around our Earth of a plane going through the center of it, makes what we call the equator, and divides the Earth into southern hemisphere and a northern hemisphere. If you go outside here, out to the ground, and draw a little circle on the Earth, you automatically divide the surface of our Earth into 2 areas. You said, I did not mean to make that great big one. And because you were thinking of the things going to infinity, it becomes very shocking to realize you've drawn the big one.
You look at any painting, any drawing, just research your memory, you find everything breaks down into lines, areas, and crossings. Those lines of Euler's take some time to be generated. And how long they take to be generated is measured by some kind of cycle. You look at your watch, you look at so many seconds, there's so many cycles, so many heartbeats. So you go in this direction on this line for so many heartbeats or so many seconds, and then you change your direction. So you have to say, what is the angle of change? In order to start talking angle at all, you have to have some line of reference. So you take, say, the line of reference between your head and your feet. So there's that line, and you observe in relation to the angle, this line of yourself. You go at such and such an angle off from the vertical, and you go in so many seconds. then you say, I now change and go in another angle, which is also describable in relation to the original line. So that we find all phenomena in the universe can be described mathematically by angle and frequency change. The frequency being then how many cycles there are that you went along any one line. Now that we then know that time is measured by cycles and lines are so many cycles long, we begin to think about patterns in a very mutable kind of a way. As for instance, I got here a necklace. It's a necklace because I can drape it over my shoulders. It's drapable. And the reason it's drapable is that the angles are all varying. The lines, which are such and such a length, because let's say one of these lines here is so many frequencies long, so many heartbeats you get from here to there. Each one of those lines is staying the same. The lines are not changing, so what is changing here is the angles. I'm going to take out one of the necklace strands. Let that go out. So she's still nice and flexible, and she can still drape it over me. Now I'm going to take out one more of those. And still is all flexible and drapes around on my shoulders. I'm going to take out one more. Came apart on me. I'd like to take out one more. And it still is flexible. You and I tend to call what we have left here at the present time a square. But it really isn't square, because it distorts in diamond, it can drape over my, it's a necklace that can hang over my shoulders like that, completely flexible that way. It can fold up into just being, look like one. I'm going to take out one more bead out of that necklace. And suddenly, a very extraordinary thing happens. No longer is it flexible. For the first and only time, I can put it on my head here, but it doesn't flex or drape at all. The angles won't change. This is what we call a triangle. Now, the triangle, if I were to take out one more, there wouldn't be any area at all. So I have a limit condition where I've gone down to where it suddenly stops flexing, which means that the angles don't change anymore. We knew the lines weren't changing at all, so it was all an angle. So triangle turns out to be what we'll call structure. It does consist of 6 parts. This edge, 3 edges, and 3 corners. And the corners themselves are something holding it together, so that we find that, let's take one pair of these sides. They're like levers, and if you have a pair of scissors or pliers, you know, the further you come out here, the more work you can do. You have more leverage advantage. So we come to the very ends of these levers, and then we put another push-pull member in here, and it stabilizes the opposite angle. So a triangle is a pattern where each side stabilizes the opposite angle with minimum effort. What we call then a structure in our universe is a complex of energy events which are inter-self-stabilizing. And the triangle is the only inter-self-stabilizing set of a complex of events. So triangle is structure. And the triangle having 3 parts, the word 3, a trace, or the word truss that you're familiar with, that's really from the Latin then, of the 3-ness of the triangle. So this has been known to man for a very long time. So when I want to build something and make it really work, I've got to use all triangles. And for instance, just look at our friend the cube. Most people think of buildings, cubical buildings, as being stable, but here's that cubical building, and it hasn't any structural stability whatsoever. The angles are all unstable. As much as we see cubes standing up, structures in men, we really want to understand how it is, and we know that they are not structural systems themselves, but the tetrahedron is the basic structural system. I'm going to show you the simplest way in which we get the strongest cubical structure, which is simply put 2 tetrahedra together in that manner. So there's your cube now, the 8 corners. Then there are 2 other structural systems in the universe besides the tetrahedron. The tetrahedron itself, we have 3 triangles around each corner. We can have the octahedron with 4 triangles around each corner. And we can have the icosahedron with 5 triangles around each corner. You can't have 6 triangles around each corner because they'd add up to 360 degrees, and that would go on to infinity. So in order to be able to return upon itself, have insiders and outsiders, the limits are tetrahedron, octahedron, icosahedron. Now, every structural system in the universe, in fact, every event, we have something called, we have an action, and when you take action, for instance, you step forward, you push the earth backward, and you see this automobile starting up and kicking these stones backwardly. Now, not only does every action have a reaction, but it also has a resultant. It starts pushing the air apart. So every event in the universe has three parts: action, reaction, and resultant. And we make these lines representing all of our experiences. We call them vectors. They are energy events, and the energy event, it depends on how much energy that is being expended, what its mass is, and what direction it's going, at what velocity, all of which we have spelled out, remember, in angular frequency. So this is one energy event: action, reaction, resultant. Now, the physicist then is able to use this kind of a way of thinking of the vectors as a basic energy event, and he has two most fundamental kind of energy events, because he has the proton and the neutron, that either one would be called a nucleon, and we find the proton and the neutron always and only coexisting. And the proton has its energy side effects. The proton has its electron and its antineutrino, and the neutron has its neutrino and its positron. And each one of those is called, in physics, 1/2 quantum, 1/2 of Planck's constant, 1/2 spin, any one of those three. Now, I'm going to put 1/2 quantum together with another half quantum. And we find, I must always put it together in an absolutely consistent way. We call that male goes to female here. So this male going to the female. And here again, I've got a male which must go to a female. This leaves me then another male here which must go to a female. So here's a female. And make that fast, and we now have one male left, and we find one female left. We put it together, and then suddenly we come to our friend the tetrahedron, which is the basic structural system in the universe. And because each one of those is a half quantum, the two together make one unit of quantum. So we now see a very important conceptuality beginning to characterize physics and all structural understanding. Now I take the icosahedron itself, and I'm going to be able to remember then that a basic unit of quantum has 6 edges, or 6 vectors. So a basic energy event has 6 vectors. We'll call that then one unit of quantum. There will always be 6 edges. And we find that the octahedron has 12 edges, or 2 units of quantum. The icosahedron has 30 edges, and 30 divided by 6 means there's 5 units of quantum. And the tetrahedron by itself has then 6 edges, or the 1 unit of quantum. If I use the volume of a tetrahedron as unity, the octahedron has 4 volumes, and the icosahedron has almost pretty close to 24 volumes. So that for 1 unit of quantum, which is 6 edges, to get 1 unit volume here I get, however, 2 units of quantum, giving me 4 units of volume, and here I'm getting 20 units of volume for 5 units of quantum invested, so that we get the most volume with the least quantum in the icosahedron. So that becomes then a very basic structural system. I use it for geodesic domes, and nature uses it for all of the protein shells of all of the viruses. Remembering then our 6 units of vector edge give us 1 unit of quantum, I'm going to take 1 unit of quantum out of the icosahedron, which has the 30 edges, or 5 units of quantum in. I'm going to take one and just leave it 4 of them in. So what I have to do is to go around taking out 1 bar like that. Then I'm going to have to take out another bar over here. And I come around and take out another bar over here. I go into the other hemisphere, opposite that triangle. I've taken out 3 so far, and I want to leave this way, so I now take one out here. I take this one out here. That's 5. Need 1 more to be removed, and here it is. So here we now have what they call the vector equilibrium with 8 triangles and 6 squares. Now I'm going to articulate it. I'm going to take this top triangle, and it must be lowered towards the triangle on the table, and the triangle on the table mustn't twist, and the triangle up here mustn't. Just simply lower towards it. So So as I start to do that, here we suddenly become the icosahedron stage. Then I keep lowering, the point still stays out towards you, and lower, suddenly becomes the octahedron. So we see a complete transformation from the vector equilibrium through the icosahedron down to the octahedronal condition. Now supposing, and we see all the vectors have been doubled up, all the edges have been doubled up, so this is very powerful. Now supposing this were a force, if I pull on it here, this forces it to contract. Supposing this were revolving in space, a whole group of stars, and another great star group here made a mass attraction and simply retarded this thing, then it would force it to contract. Now supposing this contraction and then the direction I see it coming around towards me like this, now this would make this top suddenly twist, torque, and plunge through in this manner to become the tetrahedron. So now we've gone through a great, complete set transformation from vector equilibrium through icosahedron, through octahedron, down to the tetrahedron, or the three basic structural systems in the universe. And now we see all of the vectors are fourfold. This is the way we go, for instance, from carbon, which is very relatively lightweight and soft, down to very hard diamond by getting into a doubling up of the vectors of the edges. Now we'll unwind again, up we come, back again to our friend the vector equilibrium, and we find that this pumps, sometimes it's called the jitterbug, pumping, 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 but the center is not twisting. This point always stays towards you, so we have the whole system is contracting symmetrically. All 12 points approach a common center at a symmetrical rate. We have a very extraordinary matter in engineering here. Supposing then you would have a pressure on the roof of your building, you're used to the idea of the building flattening. But if the pressure on the top of the building here means that the whole building contracts symmetrically. The vector equilibrium contains the whole phenomenology of structure of universe. And it's 12 vertices here. If we put one to the center, it's called vector equilibrium because it consists of 4 hexagons. You see a hexagon plane here at the center, another hexagon plane here, another hexagonal plane here, and a fourth one here. And each one of those has 6 radii. So the 6 radii, the 12 radii to these 12 points are equal in value to the chords, because you think, look at a hexagon, has 6 edges and 6 radii. They're equal value, so the tendency to explode and the tendency to contract are exactly balanced. That's why it's called the vector equilibrium. And they represent the closest packing of spheres around one sphere. A feather sphere here, and then 12 spheres around it. So this represents the basis of all atomic packings and so forth, and all the oscillations and wave phenomena that are articulated in our electromagnetic world.
Vector equilibrium is never witnessed by man. It is as pure as God. It is truth that is approached. It is exactitude that is approached. The nearest thing to the total patterning of all the patterns of complexity in the universe that we can find to the universe itself is man. You know what you could do, Dale? I can see you keep reaching, and I was thinking you kind of keep reaching Antarctic and going off. This is pretty good. I call it the inventory of world resources, human trends, and needs. It is my headquarters. So now I can see all the world at once without any visible distortion of the relative shape or relative size of any of the data. Now this is very convenient because also I've been able to do it in such a way what we call the sinuses, where it breaks open. All in the water, so there are no breaks in the continental contours which we have in all of our world maps. So now you can see the whole world at once without any visible distortion, without any breaks in the continental contours, which means I have one world island and one world ocean. This gives me a basic background against which we're going to study resources, pollutions and so forth. We really want to know percentages, and if you put it on a background that's very distorted, such as the Mercator map, it's you don't get the right information. But because there's no distortion, if I find out where the demographic center for all the human beings are, and I put on 1,000 pins representing each one would be 1/10 of 1% of humanity, where he actually exists. I put him on this background, and this really is accurate. So any percentims that I put on here really can be read as percentims. If math was very distorted, you wouldn't get that sensation. So this makes it possible to really study world problems and get to the pollutions and resources and so forth. This is fundamental. Each pin here is 1/12 of 1% of humanity. I want you to get a little feeling about looking at it, of the really how sparse the population in America is. About almost the same kind of density in South America, but then look at this fantastic, how Europe, concentration of people in England, concentration in Western Europe there, Italy not so bad, she's thinning down as she gets in Russia. Then there's vast distances, incidentally, between where Russia exists and where India and China are. But when you get to this area here, here's half of all humanity. Boom, just look at them. In China, the first movable type appears. You find the first balloons. You find the quaternary alloys, 2000 BC in China. Industrialization really starts there. The differentiation of tension, compression, the beautiful sails and masts, and then that went westward around the world, improving metal workers in India, getting even better in Europe with their armor making and so forth. Then they got in beginning of real industrialization. Here all the great scientists are all right in here. What is going on here is not only the accommodation of my own world around activities, which are becoming large, and I literally do live around the world, but also I have this unique function of opening up new frontiers. It could be that the world game which I've been developing here may become the whole curriculum of the university itself. My subject is that based on a very big picture. The very big picture is of all humanity now going through a transition so unprecedented, so unexpected as to be really very difficult to comprehend. And it's not just like going through the looking glass where you get a reverse pattern of yesterday. I can tell you that there are approximately, at all times now, 66 million babies in the wombs of their mothers. So 66 million is a very large number. See, it would be in the size of the nations, it would be a 10th largest nation in the world. I think all of humanity is coming out of a sort of a group womb of permitted ignorance of man, permitted ignorance, which is not a statement derogatory to man, but simply because it is the nature of the total process of regenerating life on earth, that the new life as born is born absolutely helpless and completely uninformed, though it has beautiful equipment, and being absolutely uninformed, it is very ignorant. That's what the word means. And even when I was young, humanity was 90% illiterate, and we've gone suddenly to almost complete 90% literacy, so that anywhere I go around the world, people have good vocabularies, and those good vocabularies got proliferated by the radio, getting into the homes and not through schools, and the television even more so, where they could correlate the words and the vision to see the objects, so that we have communication capability all of a sudden. But gradually discovering we do have this intellectual ability to acquire information and finding there are very reliable behaviors of the physical universe which can be employed. Democracy certainly couldn't work so long as you really have an illiterate group who don't really know what's going on and leaving it to a power structure which has all the intelligence information, makes decisions without people really knowing why. So I say we're coming to this absolute new moment when it could be that a phenomenon of democracy really might work. There are logical things that can be and should be done for all of humanity, which a democracy might really seem very spontaneous, and it's what you just do. Now, with the information proliferation that is going on around the world, this could become a possibility. And I think that is a moment we are really coming into. you're going to have to find out what needs to be done. How do you organize yourself to accommodate going from 1% of humanity to 99% of humanity who are now going to have to live and double or triple their lifespans, really give them a chance to enjoy the earth. And that is the design responsibility. So when you hear everybody out here talking about ecology and so forth, it's because the architects are not doing anything. If people could sit around and draw some pictures, I ought to feel, if I get pretty, that's enough. You don't ever have to worry about beauty or pretty, because if you really understand your problem, if you solve it correctly, so life really goes on. This is regeneration of life, and you do it most economically, so economically it is realizable. It always comes out beautiful. That's why a rose is beautiful. It is just one of those parts of the great regenerative process where there is an a priori design of the universe that had the universe working. If you want to be in part of that, you can't miss beauty. That part, your joy will be there. Your joy will be just as much as it is with a beautiful sunset. The number of people that are now talking about roofs over cities is very, very large. It's now getting to be accepted logic in the bigger planning and so forth. It's getting into the lingo. And it's the Garden of Eden. It's very small compared to talking about cities, but it certainly opens up the thoughts about such larger undertakings. Every time you double the size of a dome, your energy conservation goes up very rapidly. We get something the size of a city, and the energy conservation will be such that the enormous kinds of problems that we're having today about heat control and with the air conditioning and enormous energy power would be reduced to almost negligible. And the dome on the city size, you just would not be aware of the grid at all. It would just be not quite as bright. In this expo dome, we have a three-quarter sphere, so the walls start going away from you, and there's a very extraordinary psychological effect of this releasing you. Inside, suddenly realize that the walls really are not there. There is something that's keeping the rain away from you. It's like an umbrella above you. You don't feel shut in. Now that we know the principles by which we can cope with nature's most hostile actions of earthquakes, hurricanes, great Arctic snow loads, and now that we know how to get the best mathematics to get the most volume with the least, next thing is how do we produce the surfaces that will do this in the highest speed in the most economical, effective manner. There's no way in which man can produce material to enclose more rapidly than a great paper-making machine, great rolls. And then paper-making machine, you can also have the printing press, you can print very important mathematical information on it. So that we can make it perfectly possible then, and we now tried out making what we call paperboard domes, where you print this beautiful mathematics on it, and things, you print the folding lines, and the thing folds itself. Therefore, we can now produce on just one paper-making machine 3,000 houses a day. And these houses then coming out printed compact and beautifully distributable in the most economical manner. Paperboard domes come out about 5 cents a square foot, as against running around $2 a square foot for our usual kind of enclosure. They are being made of today of the right craft papers. We have very high wet tensile strength, very high wet compressive strength, and they can last as long as any homes we've ever been familiar with, wooden homes. If you would then have the dwelling that had the individual package, in effect a black box that did everything you needed, and this is exactly what the astronauts are going to have in order to make man a success anywhere in the universe within a very small capsule. You're going to take care of all these processes which on Earth are taken care of by an enormous ecological balance of nature. And that black box then has to be very small in order to be able to put it into space, so that we figure about 500 pounds is the limit, and it will be not much bigger than a good-sized suitcase. At 500 pounds, costing then originally $20 billion, will, however, be made out of metals that are very familiar metals mostly, very lightweight, of course. And they are, on an aircraft basis, are worth around $2 a pound. So you're only going to have a $1,000 box. And that $1,000 box just figured on an annual rental, because it will not deteriorate very rapidly, so you soon might amortize it in five years, so we call that $200 a year to buy it. And that would be your rental. So you get your black box for $200, and you go off in a geodesic dome, some beautiful space umbrella, someplace, and anywhere you want, and someplace where there's no high pressure of living, and you pick a beautiful spot just as we are here in this island. And there you can have the most advanced standard of living just out of your little black box. So that who's going to pay those high rents of which you have today, due entirely to the concentration and the lack of the little black box. You have, in effect, man within his umbrella and his briefcase, able to go anywhere in the universe and live at a very high standard of living. On the false working assumption that there's nowhere nearly enough to go around and never will be, that has to be you or me, man has then said, you must earn the right to live. You're supposed to die. You must show you're better than the other man. On this basis, then, society has been assuming that it's a handout or a socialist system if you're not earning a living at some job somebody has set out for you. So we have the idea of a job is something you have to do that you don't like to do very much, in contrast to what your mind tells you needs to be done as you'd like to do. So that the idea, then, this is the earning living idea. And we said we don't want you to feel like pick and shovel kind of a job. We do that by the bulldozer. We don't even want you to be blue jeans. That's kind of gets your hands dirty. We want everybody to be white collar. So in order to have everybody white collar invent the jobs, we've had to invent an enormous number of buildings. So every one of our cities is filled with great buildings to accommodate these people working. Now we also have the real estate are saying it's very unhealthy for the butcher to sleep with the meat. So every one of our cities is filled with fantastic great buildings today in which nobody's allowed to sleep. Therefore, at night, we have all typewriters sleeping with all the beautiful plumbing and all the people sleeping in the slums without any plumbing. So what we're going to do is to simply make some sense now and say, I don't want you to be taking a job where it's not what you really like to do. I want you to know, go back to where you were a kid. What were you thinking about when they told you how to earn a living? I'm going to give everybody a fellowship to think. Out of every 1,000 you give such a fellowship to, one will make a breakthrough, will pay for everybody. So we're going to afford it easily. So we're going to say that. The minute you do that, those people are going to leave all those buildings. They won't come back because they don't need that money for that fake job. And we're going to move all the people out of the slums right into those beautiful buildings. So the urban problem is actually completely solved today. People say to me, I wonder what it'd be like to be on a spaceship. And I say to you, you don't really realize what you're doing, because everybody is an astronaut. You all live aboard a beautiful little spaceship called Earth. What is now as clear as the speed of light itself is our realization that we've come to enough knowledge about how to do so much with so little, to understand enough about our great universe and man in the universe to realize his function is that of the mind, ability to bring great order. And we have the beautiful realization that Einstein's great conceptioning can go from weaponry to livingry, and it is now practical. Metaphysical really master the physical. This is what man tends to call utopia. It's a fairly small word, but inadequate to describe the extraordinary new freedom of man in a new relationship to the universe, the alternative which is oblivion.